No. No questions are the first five. Check answers then. Question number one. Did you get A? Question two, A. Question three, boy. Question four, donkey. And question five, A. Anyone get anything wrong or don't understand why the answer is such or not?
What question?
What?
What's three?
Three was boy. Did you get correct? Yes, guys. Anyone with any question for the first five?
Question is this.
The first five.
Is to
Okay. Anyone has any questions or not? What are the next five? Is this five? Yeah. Next five. Any question? Anyone that you couldn't do? No? Check answers then. Next five, guys. Question 1A. Question 2C. Question 3, donkey. Question 4, boy. And question 5A. Any questions or not for the next five? Everything correct? What about you? Okay, both of you guys? Everything correct? Okay, good. No questions, then moving on to the next part. The last five. Is this the last five? Yeah. Check answer. Question number one. Boy. Question 2C. Question 3C. Question 4A and 5C. Boy, C.
Wow.
Any questions? I thought you said you got a lot of questions you didn't know. Why don't you ask? What? If you don't ask, then how you will know? Huh? Okay. It's very weird, but you're supposed to ask if you don't know because I'm here, but sure. Guys, anyone want to ask anything or not? Anyone want to ask anything or not? Wow. I feel that you guys need to be a bit more proactive for chemistry. No questions, right? Do the next part. Everything. Until you see this one here, extraction of metal.
Bye. Shut up. Let's go 4 to minus 3. Let's go 4 to minus. So, let's go 4 to 8. This is something you know, more trees and
Yes.
holy shit!
If you find out the find the formula. What is the formula for iron 3 sulfate? So right. You're gonna mess with all right, because things first is you need to know what the sulfate is. Right. What's the ion of sulfate? S O 2 minus 1. Right, SO4 2 minus, right? Let's put that. Then you see, this is iron, right? Iron is going to be selling E. But you see this bracket 1, 2, 3, what does that mean? Yeah, no, it's here. P plus. The ion for iron is at E3 plus. If let's say I say iron 2 sulfate, right, then it will be 2 plus. But in this case, it is 3 marks, so it's at E3 plus. So then after that, how do I combine those two things? How will it become? Good, can you become Fe? Right here. Just at first, this one you don't know, man. Follow the periodic table. What is this? From the position. What do you think? Is this mg1 plus 2 plus 3 plus minus 1 minus 2 or minus 2 or 3? 2 lah. Let's be 2 plus lah. That's right. Yes.
Mg. So the variable of fusion Mg plus.
This chemical. Good. Good. Yeah. Good.
Is this one because there's something as copper chloride? This one copper sulfate.
Copper chloride. I don't know. Never see before. But maybe.
What?
But maybe I don't know.
This one is this one.
Man. Actually, right. I don't know why this thing is 3 marks. This is a very simple way to tell whether this thing is more reactive than this thing or not. No, very popular. I see. I see which one goes faster.
So I did it for this one.
Let's see.
Isn't it? Why use displacement when you just throw the bottom? Show displacement not actually you idiot or don't train water is acid not that. Copper can react with acid. Acid 不会你就知道不可以啦，怎么会？因为它 reactive。不可以的 acid。Switch it up, boy. Okay. I mean. Let's see. Yes, copper can be react with certain acid. And copper no. And then 1 minus
Yes, is everyone done with the first question? Can I discuss the answers?
Oh yeah.
Yeah. You will not react. That's hard.
Shoot. Manganese or okay. Your table. Manganese or real acid.
Yeah.
Only
3 things will not react with acid. What are the 3 things?
those 3 things at the bottom.
Copper, silver, and gold.
Yeah, I think I said copper won't react with acid. He was arguing with me why use displacement. So
You can use displacement, but it's
he said this over. He said copper will react with acid.
you have to use very concentrated and strong acid, then it will react. But generally, it will not.
Exactly. So I said. Oh, yeah.
Yes, Sarah. Potassium does not form colored compound. That's not a physical state though. We're talking about this chapter, right? This question, right? No, cannot.
This is high
Melting point.
boiling point
Cannot.
physical property of chemical.
Yes, it is.
Stupid.
Physical. That's my
I
friend.
didn't say you're wrong.
Oh. So right now, right, you want to test whether this thing or this thing is more reactive, right? All you need to do is just prove I said, okay, usually this case they're not on the plan. Because if it will take an extra, you'll notice that it's just not reactive. Anything so this and this both include different test tubes and the same consequences observed for reaction. This thing starts bubbling and form hydrogen. This thing is from and this thing is not doing this thing. Alright guys, check answer for question number 1, guys, is relatively straightforward. Please see if you got the same answer or not, guys. So for question number 1 here, obviously is sodium and lithium, right? That will react most vigorously with the cold water. And the second one will be the bottom law, which is copper and rhodium law. Very straightforward. For this one here, how many of you guys got this correct? The third one. Good. So what I want to emphasize is that first and foremost in this question, guys, you're supposed to remember what a sulfate is, right? Which is essentially S what? O4 what? 2 minus, right? It's basically SO4 2 minus, right? If it's SO4 2 minus, the next thing is you want to know what this is. Iron is definitely Fe lah. You all know this by now. But what does this 1, 2, 3 mean? Power 3, okay, is supposed to be positive 3 oxidation state, which once again goes back down to stoichiometry, right? What should I do? Good. Swap and drop. So it's going to be Fe2SO4 3. We bracket the SO4 3 because this thing is together, and there's 3 of it. Okay. And this one, what's the answer? Mg plus. How come it's Mg plus, my friend? Group 1. Group 1. You're supposed to refer to the periodic table. The only time you don't refer to the periodic table if it's a transition metal. Right, everything else I know for sure this will be what? 1. This will be
2,
this,
3,
this,
5.
5 positive or negative or?
Negative 3. No, positive 5. Positive 5. Negative 1.
Negative 1.
Negative 3.
Then this one?
Negative 2. 26. Negative 4. I'm 47. Brother.
Hey, this one is very straightforward, guys. You know to test which one is more reactive, you just place both of them into acid. Right, both of them you put some acid of the same concentration and same strength, basically, right? You throw one manganese inside and you throw one copper inside and you observe for a reaction. Most likely this thing will have no reaction, where this thing will start giving off hydrogen gas. It will bubble and form hydrogen gas. I know that this thing is more reactive already. Write it in your own words. Yes.
Yes.
Yes. Okay, then this one here, chemical and physical properties. What's the physical property of a transition metal, guys? It's damn hard one. And then
High boiling.
high boiling point, and then
High boiling point. Dense.
okay, high density, good, correct. Right. Then for chemical properties, it's always it acts as the catalyst, and color compound is color compound a chemical property? No, right? It's a physical, isn't it?
Oh yeah. I thought it was physical.
You talk now. Where's the knife? Behind the knife. Go tell. Catalyst, variable oxidation state. Where?
Number 4. Oh yeah. Oh, same thing.
Is color compound a physical state or chemical state? It's considered a physical property. Why is this here though? I don't understand. Whatever. Don't write it in a real exam. Oh, you don't write it in a real exam. It's a physical property. Huh?
variable.
Yeah. Okay, please attempt question number 2, guys. Please attempt question number 2.
Yes. Looking forward to your wedding.
Fine, good. I'm so good.
You better finish this one. Now. I want to be one.
What?
You want?
Oh no, thanks.
Elizabeth teaching. The history and no, like it's not that you. No, dragon 知道是不是 crispy 的？吃抖音里有什么问题？你要肥了，我没有啊。我要肥了，给你个 dragon 没问题吗？我跟他讲，我跟他讲他肥了。Fuck you, man！真的是多一个嘛，我要你 try。It's nothing, that's not gonna hurt your body, bro. Really good. I'm really good. L. The gene here.
All you do is Jean, Chloe, Jean, Chloe, Jean, Chloe.
Chloe, that's not true. Chloe, fish Chloe. Fish Chloe. 我直接啊。哦。
Sarah,
Jean 不知道你有没有
is it gonna be a problem for you for chemistry? Are you gonna struggle with chemistry? So how do you want to study? How do you want me to help you?
开玩。This one actually that is me. You didn't mean that one?
But ChatGPT cannot bring into exam. So how?
Monday.
How do you want me to help you, Sarah?
Confirm? One hour.
Huh?
老师那要什么？
Never mind. You think about it, okay? You think about it, then you let me know how you want me to help you.
没有理由不能吗？你好，going to yeah.
You guys go there actually want to do it.
Obviously. We done to the book.
No.
Obviously,
We're
then
gonna bring everything there.
what are you gonna do? Like 3 A4 papers, not 3 like 10 10 A4 papers. 多少 workout 啦喂。Chloe should date. But no, if you say you want to date Chloe will date you with you, bro. I know, and she'll come to you like a storm. You already told me. Hey, L, confirm again or not? You confirm?
Like, go there just to I'd rather go like.
Bro, I'm saying, like, go to do swimming. Did she not tell you we're gonna go on the partner?
Hey, have we learned about reducing agent yet?
What means me? We don't have no guy. We don't reaction what?
Oh yeah, I remember now. Yes.
The main thing for that is.
Yes.
Oh, wow.
We're gonna eat at 12.
Oh,
Somebody at
nice.
1.
I bring a bag. It's like this big. How am I gonna fit 10 papers in that so? But I'm not bringing this bag. I'm not. Well, you're gonna bring like a whole bag with like all your pencils and everything for. To really like.
No, I'm not bringing a designer bag. I'm bringing like I'm bringing
like
like a laptop bag. Basically, like this was smaller.
you also like
According to the. Have you done that with first aid? Any of the struggle or any of the holiday work? I also started with physical. You guys got holiday homework? So much, bro. Hey, MS was work. I didn't know anything except for physics, bro. Yeah, I'm so behind now. You just. Oh, man.
I mean, I don't have $100. But how do you tell that? You sign it, you look at. or that 50%, yeah.
Hard to do.
Huh? There's your like,
Methodology
you're seeing picture.
doesn't even,
That's
does not count.
I mean, it says like year 10 year like okay, right? That makes sense. I think sometimes it's
It looks, this is
start change identity. These kind of questions, then after this conversation, it's going to be the same answer. I think that doesn't think.
Now that is the mileage.
and now.
So we can base, this is the way to handle it. Yeah.
Wi-Fi open.
Well, my favorite one, is it's on the. Sometimes they
But you do run out of data in this time stage,
just
and the data is really quite a lot right now, really. Okay, the difference in physical computing and transition metals. Transition metals is always the same compared to one, even though both of them are basic. Transition metals are usually harder, they have a higher density and they have higher melting point in relation to one. All this, the three differences. Yes, transition metals are always harder than one. But it's answer that was not so easy to know and so how do we know what's wrong? Yeah.
No, but that's. He said, I said, simple as for reading through secrets of things. Discord. Discord.
If I don't know, do you believe it's so?
1 month. Hey, what did you do last week?
Yeah,
Stupid.
This question now, they're saying rusting of steel can be prevented by coating steel with a layer of zinc. Why zinc? Why not anything else? Explain in terms of electron transfer. Okay, first question.
My God. What do you do?
because
I'll ask people that better.
No. If anything, zinc is more reactive.
I don't know.
But what calls so vibrant.
What's the difference?
This one so like you really have those are
Yes.
think it's even more active than iron. That is why we usually galvanize iron with zinc. We galvanize iron with zinc because when you have a layer of zinc, that is iron, right? When we have a layer of zinc, what happens is, right, even if I chip this layer, this thing is touching this thing here right now. And then this thing would have a higher tendency to donate electrons or
So that.
yeah, the characteristic will rust, have a higher tendency to rust. Whereas in terms of rusting, how do we relate it to electrons?
So this
What is good because of oil rig, right? The oxidation is lost of electrons. If it rusts, electrons. This is what is scrolling right here. Instead of scrolling the content out,
I know now.
please at least scroll ChatGPT.
I think I was supposed to be. I don't remember. No, I was there with the.
What you prefer, more reactive level, as like the surface. Still use.
Yeah, correct.
Now it's more reactive.
Hello.
Yeah, as long as it's more reactive, anyone here will react. But you cannot beat this up because these are two reactive activities. Even before you touch the water, before you react, you want to get it.
I did. Oh, that's my ID. No cap.
No,
It's not my mom.
Can, you can.
And now, I'm trying to run together, I'm trying to find a place to run.
You can, but
Why
I clarify, you must be confused and lost because you were here for the last 2 years. You're supposed to do everything. What I can recommend to you is go YouTube, right, and search up on this one, the reactivity series. We'll watch as much as you can. And you watch about this one, displacement reaction. Then after that, you read up on barrier protection, galvanization, and sacrificial metal. They have everything there. You have to go look through it. Yes, and please ask questions if you don't understand, especially after this stuff.
What is question 3A, bro? You got it,
Okay, you answer me what's happening here.
doing what? No, answer him. Who was that you? You're so step over today. Okay. This one, hold on, please.
Wait, so there was that law. So the bands.
Because yeah, so the notes given to it's because it's galvanized.
Meaning,
When it's flat, right, it's still protected by sacrificial. What is it?
So right now, this question here, the two things, they say this steel, which is mainly made of iron, it's a lot of iron, right? It's degalvanized, I think. Right, they ask you to say in terms of electrons transfer, which you're supposed to refer back to here right now. Right, iron is below it, right? So which one will have a higher tendency to rust?
Zinc.
Zinc has a higher tendency to rust. If zinc has a higher tendency to rust, you think about rusting, what is responsible for rusting? Oxidation or reduction? Good. If you think about oxidation is responsible for rusting, then is it gaining electrons or losing electrons? That's right. You get it.
What do you need to so you just write
You can refer to
only the first page. This one, no, I mean this one got circle. I swear got circle. I was checking his answers, I didn't circle the first two. The last time I got checked. I mean I got circle because he didn't do.
pretty good. Answers from here.
Okay. Yes.
Congrats. How can I help you?
Oh, wait, Melody. Oh, Melody is not Australia. No, it's how to spell Melody, the one like Melody. Melody not stupid. MELODY. Melody or Melody. What's that Spanish?
The
The cartoon of Melody. I sent it to her like.
For like an event we had, she dressed up as a Melody.
Bro, her whole life is like changed from Melody. All the stickers she own now all Melody. She gave me the Melody sticker. No, I was like, this girl, I hate Melody, when I send the Melody. It shows me the back technology, but I think it's Melody, okay? So, no, it's not required, what is? You have to change it. Yes. I didn't say anything. Just go and say.
Yeah, right. Hey, can you start with reading through all the questions first?
It's gone. I didn't back. Huh? No, what did she say? She is your girlfriend. Now, she wish her.
Guys, let's go through question. Guys, let's go through question 2 together. Since most of you guys who know how to do it already know how to do it. Guys, for this part here, the 3 differences in physical properties between group 1 and transition metals are literally the same answers as what you put on top here. the transition metals are always harder, higher density, and they have a higher melting point, which is always the common answer in terms of their physical properties. Right, so nothing much to explain there. It will be literally the same thing. This part here, they already tell you the metals are ordered in reactivity already. This is most reactive, this is least reactive here. For those metals which react with water or steam, name the product of reaction, otherwise there's no reaction. First question. Got reaction ah? Got reaction ah? Got reaction ah? Which one no reaction? Only copper has no reaction ah. This one for sure have reaction, right? What will it produce? Hydrogen and
water. No.
water.
Dense.
Okay, potassium hydroxide and
Yes.
yeah lah, it will be potassium hydroxide and hydrogen, and then
That's all.
for zinc, guys, it will be zinc oxide and hydrogen, guys. Why? Why this one hydroxide? Why this one only oxide? How come? One is water, one is oxygen.
One is
Yeah.
because
But steam is a form of water also, right? The answer I'm looking for is because potassium is considered a alkali metal. So if it reacts with water, it's going to produce a alkali solution, which in this case here will be potassium hydroxide. Whereas zinc is not. So it will only form into zinc oxide. But if you look deeper here, they say that zinc and yeah, they don't mention. They don't mention in the answer, guys. But I want you all to know because potassium is an alkali metal, and when it reacts with water, it will form an alkali solution, which in this case here will be potassium hydroxide. Okay? Yeah.
You only need to name the product. You don't need to say that it was very risky water. And it's going to water. It's not a secret dish.
Yes. Yes. I think you louder. Yeah. What stop.
Your statement again, space is oxygen and then water is water. Oxygen is oxygen. Steam is still water. No, your steam is still under your water category. Oxygen is in the different category. Steam is like yeah, steam is literally like oil, water. It's called steam. It's still under water. Yeah, it's
Alright, next. Okay, then this part here. You answer me. How do I write this answer? How come rusting of steel can be prevented by putting a layer of zinc? And explain in terms of electron transfer. Okay, zinc will galvanize the steel then. What happens? How come zinc will galvanize the steel? Why don't we use copper to galvanize the steel? Good. First statement is that the zinc is more reactive, right? And because of that, when we coat it, what happens is even if there's a chip there, they are still in contact, right? And because of that, zinc will be the one that is going to become the sacrificial metal and oxidize. And in terms of electrons, it will
Stop.
it will what? Gain or lose? Gain or lose electrons?
Lose.
Guys, I want you all to remember whenever rusting occurs, it's due to oxidation, right? And if you remember the word oil rig, guys, oxidation is loss of electrons, right? And thus it's supposed to mention that the zinc has a higher tendency to lose electrons instead. And that's your answer. So if you look here, oh my God. Yeah, write any of these four down. Please, especially those that did not get the question correct, please write this down.
No, actually, just smell of you. Oh, that's not very. Sorry, the moment that you why you there? You see, because that's not stuck in the mouth. First, it be this like mouth, then you like that's like mouth. Oh, so you Google just like mouth. That's good.
Okay, continue doing the next question.
You know what's SN2?
What?
What's SN?
Tin. Tin ion. When they say it's SN2 plus, most likely means to say that this in an aqueous solution. That's why it becomes an ion.
Okay.
It could be any solution. It could be like zinc sulfate or zinc nitrate or zinc. Zinc potassium. What? What's the P stand for again? For snap.
This
Sulfate, nitrate, potassium. Wow. Wait, let me double check.
lead.
Did that?
Also, lead. Zinc potassium. Zinc potassium.
Oh, it was potassium.
You in the corner is your mind. Chacho. Sorry, if I'm gay, teach you again.
Okay. Anyways, the 2 plus here indicates that it's in the aqueous state.
Okay, I don't know how to do that. I don't, you know, learning any of this.
Because you were always not here.
I was only learning last week. She's there. Okay, so right.
Wow. And here, okay, that was in the discussion.
You know anything?
Possibly not. You always pick the important ones. Right now, they give you already, right? This is most reactive, followed by this is the least reactive, right?
if I have copper and
No reaction.
no reaction, then this one iron and zinc. No, not reaction, what's gonna become the tin, sorry, the iron will displace the tin, right? So I don't know what's the combo, but you don't have to write that. So you just need to write Fe2 plus Sn. Because the Sn will be displaced outwards already. Yeah, it will be the same understanding for the third one also.
What's SN? Sorry, what's SN and SN2 plus? What is
I
it?
told you this is the ion which is in the liquid state, like for example, copper 2 sulfate liquid, right? Inside that liquid there's Cu2 plus and there's SO4 2 minus.
There's a slide.
Yes.
No reaction. NR. You know what is like finally. Molar mass.
No reaction.
No one's smart because I don't really know yet. How to what are the three products form and
In terms of analytic equation, you have to mention which one gains electrons and which one loses electrons.
you know
You see, this one, right, becomes this, right? And this one becomes like that. Like that. That ionic equation must write in terms of electron.
makes sense.
Yeah, this one gain electron writing to something. The E must be on the left side or the right side of the equation. Yeah, this one would be the right side. So it'll be like PV becomes PV2 plus 2 electron, right? And this one,
No, or like
this one loses electron. Sorry, this one loses electron, and this one gains electron. So this one will be like Kg plus electron becomes K2.
It's what's the next one?
Is this the last question, right?
Yes, one. No.
Yeah.
Hey, what? Hey, wait, what? Yeah, the last page. Hey, no, my last page is just the same as this. Oh. Isn't that the last page? I had the last page. But see it the form.
Oh, I know why. Because of the stupid printer.
Yeah. So this one C is basically the same as K.
1C. Yeah, it'll be the same.
Has issue.
Guys, let's go through the question together for this one. Okay, guys, I want to highlight this since some of you guys, you've been asking me the same thing. Do you know what this 2 plus means or not? This 2 plus is indicative that it is in an aqueous solution. For example, if let's say I have a aqueous solution of copper sulfate, right? It means to say in this liquid, there is basically Cu2 plus in it and SO4 2 minus in it, Right. So whenever you see this word, the equation, they show that there's 2 plus here, right? It basically indicates that it is a aqueous solution. That's why there's free moving ions inside. And then from here, the next question you want to ask yourself is copper more reactive than tin? No, so definitely no reaction, right? There'll be no reaction. Then the next question is iron more reactive than tin? Yes, it is, because iron is above tin, right? So I know that iron will actually displace the tin in the solution, right? What solution will it become? I don't know, but I know that ultimately it will become Sn plus Fe2 plus in terms of the ion exchange. Okay? And finally, this one here, Sn, which is tin again, and zinc. Right, this thing is below this thing here right now. So it means to say the tin cannot displace the zinc ions, right? So once again, there'll be no reaction here. Same thing. The same thing. Fe2 plus Sn will be the same thing as Sn plus Fe2 plus. Because 3 plus 1 is the same as 1 plus 3. Okay, this one, maybe most of you guys do not know this. And in fact, I'm not expecting you guys to remember this. Whenever I honest with you guys are, these kind of questions, right? They say heated, right? This is going to be what? Good is thermal decomposition, which means to say one thing will break into many things, right? I can say lah, most of the time this is a gamble lah, even for me also, right? So first things first is my gamble would be, because I see nitrate there, right? Then definitely going to be what? Or nitrogen, no? Right? Then oxygen, good. Then it's tin oxide. It's a gamble one. You after a while you know what to write, but for now you have to gamble a little bit lah, right? And in this case here, you'll have to write. Shit, where is it? That's my answer. That's my answer. Oh, tin oxide. Oh, actually, they give multiple answers and this one. Oh, yeah. You can write multiple ones, but then usually lah for decomposition there will be oxygen lah. Unless there's carbonate, then there's carbon dioxide. Yes.
Yeah.
Yes, write these 3 down. You just have to have the idea that it breaks into 3 things. Okay? And finally, this last question here is literally the same question as we did just now. Okay. Oh, it's not. It's tin and zinc. It's not the same. It's tin and zinc.
Is it not almost the same?
It's definitely not the same.
Oh, zinc is less reactive than zinc.
Tin? What?
Tin is less reactive.
Yes, tin in fact is below iron. This is more reactive than this, but this is less reactive than this. If today I put iron and tin together and they're exposed already, okay lah, if let's say I fully wrap the iron bar with tin, right? Most likely no oxygen goes in, right? Then okay, fine. But what if I have a chip there? Then right now what happens? Who's the sacrificial metal?
Steel. The inside one.
The iron will be the sacrificial metal, which doesn't make sense. So you cannot use tin to wrap iron, because if tin and iron were together, the iron will become the sacrificial metal. So you must use zinc, guys. And the mark scheme will say something similar, blah, blah, blah. Yeah, write this down, guys. Yes, the more reactive it is, the more likely it is to oxidize and lose electrons. Good. Correct already. Good.
Wait, what do they have one extra question? I don't have that.
Really? What? This one? Zinc corrodes. Zinc corrodes means to say it is more likely to oxidize and rust first. That's what corrodes mean. Sacrificial protection. Sacrificial protection is when you place a more reactive metal on something that is less reactive so that it sacrifices itself. Like in this case here, your zinc. Nickel lead? Yeah, right. Yes, please attend the lab. At least now you can do a big talk. Everyone done already? Yeah, the last question. Supposed to look at it based on the reactivity. Yeah. This supposed to look at it from okay. This action. This thing, just see basically this thing. I used to say this thing is more reactive. This I supposed to look at this thing, like this thing, this thing. Usually this is more reactive. Let's make those values. You can have it from this paper. She's done already. Can tell. You slept through the whole physics class. How? Wait, how long have you been here? Only 1 year. Okay, really. Before this, in Japan. In Japan, how's their English? I want to know. Do they learn English in Japan?
No. Islam.
So you guys don't speak English at all? No English class? You know when I was in Japan, right? Japanese people very nice one. They absolutely have a communication breakdown. So if let's say I need to go somewhere, right? They'll tell me, oh, I know. Yokata, right? Yokata is understand, right? I'm sorry, wakata is understand. Right? Japanese, very good. I love Japanese. Korean, very bad. I hate Koreans.
What?
Because Koreans are shit, bro.
Is she in the meeting? Is she in the meeting?
Oh, she's not. I'm not saying everyone, right? Just like how not everyone is bad, but Korean, wow, I tell you, I went to Korea and it was like, I hate the Koreans, man. Seriously. They're very rude. They're very egoistic. Japan is good. They're very helpful. Serious. Yeah. Yeah. You know in Malaysia, right? Let's say right? I go 7-Eleven, right? Let's say the amount of money is 740. So I'll give 1040. So you give me back $3, right? The Japanese guy looked at my 1040 and like, give me back the 40 cents. Then you press into the calculator, 260, and then you give me back 260. I'm like, yeah. That's so big. I'm like,
Maybe not Japanese.
no,
Japanese bad.
no, he bad. He was bad. He was in 7-Eleven.
No. Most of 7-Eleven cashier from foreign country.
Really?
Oh yeah, I went to a 7-Eleven for like 70 baht and
Yeah, sorry. So not 7-Eleven, Family Mart.
yeah.
Yeah.
It was like all Bangladesh people.
Hey, this is 100. Yeah.
Yeah, but I love Japan. I'll go back to Japan, but I'll never go back to Korea. No. Okay, guys, last question for the day. Before I release every one of you guys, especially the animals at the back. Okay. Hey, how come this? Oh no. Okay, guys, last question here. We'll talk about reducing agent. Guys, for anything to be a reducing agent, it itself must be good. So based on oxidation, we need to see which one is getting more, either an oxygen or its oxidation number increase or it is losing electrons, right? Which one fits the criteria? Nickel, because this guy here, number one, the oxidation state from 0 turn into +2. And number two, it is losing electrons. That's why you can see that the electrons is on the right side of the equation. Right, so obviously nickel is the reducing agent because it's being oxidized. And the reason... Wait, can shut up. And the reason is because of what? In terms of electrons, how do I mention it? It loses electrons. What? Wow, it's not wrong, but they must.
Reducing the oxidation state of matter.
Cannot. Too long. Usually, if they talk about oxidize or reduce, you talk about electrons, which in this case here will be losing electrons. And then the general term where one electron is transferred to another thing, it is just known as redox reaction. One guy will accept electrons, one guy will donate electrons. Right. Then the last part here already, I need to know which one is most reactive, from which I look at the first equation. You see how this thing was solid and this thing was in an aqueous state, right? Right now, this thing displaced this thing, right? So I know that this thing is more reactive than this thing, because I literally stole it away already, right? I stole the boyfriend away, right? So first and foremost, I know nickel is more reactive than this lead here. Then after that, look at this equation. The lead actually displaces silver, which makes sense, right? Because silver is at the bottom of the reactivity series. The only thing that cannot displace silver is gold. So I know that definitely Ag is at the bottom, Pb is on top of it, and then nickel is on top. Yeah. Which one? Okay, so if I were to draw the full equation out, let's say this thing is, I don't know, Pb nitrate, or okay, Pb sulfate, let's say nickel plus Pb sulfate. Right now it becomes Pb plus nickel sulfate. Something like that. So right now this thing literally stole the girlfriend away, right? Which means to say this thing is more reactive than this thing, right? Makes sense, Yes, they only write the... I don't think this is the ionic equation. Yeah, the ionic equation only. That's why I say this thing, if it's 2+, it will usually be in aqueous state. It has to be with someone else on. Yes. Did that clear your doubts? Yes, good. Anyone has any questions? Oh, really? Oh, damn. Okay, shit. So right now they asked about the half ionic equation, right? Half ionic equation always has to do with electrons. One guy will be accepting electrons and one guy will be donating electrons. Looking at this one and this one first, do you think this thing had to accept electrons to become 2+, or did it have to donate electrons to become 2+? You answer me. You answer me. Donate or accept electrons to become 2+? It's donate. Why? Because when I donate it away, I'm throwing away my negativity and then I become positive. I donate my electrons away, which are negative, then I become positive, right? That's what's happening here. And if I have to donate my electrons away, usually the electrons will appear on the right side of the equation. So it will definitely be E plus, in this case here, Pb2 plus. But right now there's Pb2 plus, so I have to have 2E here to balance off the 2 plus here. Did you hear what I said? Are you looking at the screen? There. Do you understand this part or not first? It's on the electron is on the right side because I'm donating the electrons. Right, you see this thing out which is positive initially, right now becomes zero charge. It must not obviously accept electrons, right? In order for it to accept electrons, it has to be Ag plus electron. That's why I say the electron will appear on the left side of the equation to become Ag. This one, the electron will appear on the right side of the equation. This is donating. This is accepting. Yeah. No. This one? Oh, yeah, you do. Huh. You don't, right? This is just one PV, but it's two charge. I don't think so. Yeah, no need. Because this is just the charge. It's not the amount. This is still one thing. This is still one thing. Just that this is 2 plus. It lost 2 electrons. It's not two things here. It's one thing only. Okay, my boys.
Oh, they.
Yes, that will be it for today, guys.